Making programs in C++ is easy and fun. And today, I'm going to show you how to make a simple console program in Visual Studio. You can use any IDE. IDE stands for Integrated Development Environment, but I prefer to use Visual Studio. I'm using specifically Visual Studio 2026 Community Edition. So, if you want, you can use this one. It's actually free. To create a project, click Create a New Project. And the installation phase, it'll let you choose what languages you want to use. I won't cover that specifically, but it'll be pretty obvious when you see like desktop applications. We'll click Empty Project. Of course, there is Console App, which includes some code by default, but we'll start from the empty project so I can explain every piece. And we'll place the project in a folder of your choice. I prefer to put it in a dedicated little development folder, and I'll call this tutorial app. And then hit create. Okay, so with the application open, with Visual Studio open and the project open, you will see nothing for now. Let's fix that. By right-clicking source files and then clicking add, we can do new item, or you can do Control-Shift-A right there. We can make a source file. So that ends in .cpp. C++ is what that stands for. And we can type in main. You can name it what you want, but generally, the first file, and like for single source file programs, like a basic console app, the source file will often be just named like main or something. But sometimes it'll name it after your project if you use certain other templates, like the default console template, instead of the blank template like we're doing so right now. So now with this, we can begin coding. So let's start with hashtag include. Hashtag include includes these. You see these? These are different libraries. These are different like things you can import. You'll see they all end .h. The .h stands for header. And these header files, they add functionality. They add the ability to do things. Like if you do hashtag include windows.h, you can do stuff with Windows, which is useful if you want to do like a Win32 GUI application. But that it's a bit antiquated, but in my opinion, it's pretty good. We'll go ahead and do IOStream. This is probably the most basic but powerful library there is. So with IOStream imported, let's define our main function. Sorry, not imported, included. Difference in Python is C++. int stands for integer. It's any it's any number that is not a decimal number and is a whole number actually. So that can be like -4, 8, that I don't know what that is, like 100,000 or something. I just typed in random zeros. And that is what that is. So int main parenthesis curly brackets. Boom. This is the main function of the program. When the program runs, the system will run this. This is, oops, don't scroll, come on. This is the main function of the program. I think I just said that, just so you know, it's the main function. And whatever you put here is what the system will run. And it will just go down until there's nothing left to run, which is generally not good practice, or when you return 0. The return 0 indicates that the program ran successfully without any issues. So, what do we do here now? Well, we can do something like std, it stands for standard library. 2 colons to indicate that we're getting the thing from a standard library, right? I'm simplifying this right now. I'll go more in depth into the little intricacies and nitpicks, but for now, cout is being derived from the standard library. And then these arrows, basically imagine them like we are putting whatever is right here into the console. We're putting it to the console output. We are outputting it to the user. Hello, world. It's a classic first program. It was mine as well, actually. It's my first program I ever wrote was Hello World in C++ many years ago. It's fun times. Anyways, let's do another standard : and L semicolon. Great. We have written our first statement. So this little end L, we're going to imagine it like end line. It does more than that. But for the sake of the tutorial, and generally, actually, it just ends the line. So when you put hello world, it'll output something along the lines of this. Put hello world, and then go to the next line. You can also do something like this, and it will output hello world. But if you print more text afterwards, like get rad, it'll output it like, actually, why don't I let it demonstrate? Let's see what happens. You'll see it'll put it right there, sort of next to each other. Bit odd. If we do something, oops, sorry, forgot to put the std, the standard library. You see, it starts a new line. But you may notice that writing down this every time may get tedious. That's when you might want to do something like using namespace std. This basically automatically adds this behind every applicable statement. So it lets the program, no, not the program, lets the compiler know that we are in the namespace here. So that's exactly this right here does this, except on the individual basis. And this does it pretty much for the whole file. So we can go ahead and do something like that, and it will still work. Now, what do we do now? We got the hello world, we got get rad. We can also start a new line like this, by the way, but generally it's better to do this for technical reasons that I will get to in a future video. But what do we do now? We got main. Can we take user inputs? Yes. With cin, we can go like this. Geez, where do we put the input? Good question. That is where variables come in. Variables are used to store data, and you might have noticed, this might have looked a bit familiar actually. Right here, integer, what I was talking about earlier, integer is like a type, it's a data type. So we can do integer, we can do booleans, boolean store yes or no. We can do char, stores a single character. We can do floats. Floats store numbers, but they include decimals, and you can actually do more precise math, you know, but there are floating point errors that can occur. So when you're doing something like science, that can actually interfere. When you're doing something like video games, it's not that big of an issue, unless you're playing Kerbal Space Program at high speed acceleration. But that's not important. It's neither here nor there. Right now, we are here, and we're going to go ahead and create a new variable to, what are we going to do? We're going to get a string. You might have noticed like string is sort of a thing, a way of saying like a series of words. A good way to see, like to think about strings is, you know, char is like a character. Imagine strings just as an array of characters. And if you're wondering what an array is, an array, it's like a collection of things in an order. So you could have something like 1, 2, 3, 4, this, like something like this. It won't actually be exactly like that. I'm just using the square brackets to demonstrate how each little piece of information in the array is in its own slot. So you have the 0th slot because lists and indexes, everything will generally start on the number 0 in programming, in computer science. So it has 0, 1, 2, 3. And we can replace this with letters. And so that means the 0th character of the string would be a W. And that's how the strings work. So user input. We have the string called user input. Also, this light bulb will appear and it will give you hints sometimes. You'll see a little 3 dots right there. It'll like do a little highlighting. And sometimes if you're like having an issue, like right here, expected an expression. I don't know what that's about, but oh, that's because of this thing. But it'll generally help you sometimes. So that's just a cool thing to use. That is AI. I don't care about that. But right now it's telling us you should include string. So, oh yeah, look, see right there, you can actually see, if you hover over it, you'll see using std string equals, well, you got all that. And right there is the local variable. If you hover over things, you'll see a little more about it. So we hover over this. This is just this is const, means it's constant. Can't change it ever in the program. Char 9. So this is an array of 9 characters. Get rad. Spaces count as characters, by the way. And it's right here, a string. Hello. You'll see it's a bit more intricate, but let that be. So what now? We have user input. Let's go ahead and take that into here. So when the user is, after it says these, it'll wait for input. So when you have sin, actually, it's going to leave a blinking cursor like so. Here, let me demonstrate. We'll have a blinking cursor and nothing will happen until the user enters something. Let's say hi. It closes because it got the input. It put it in here, but it did nothing because we haven't told it to do anything. Let's see what happens if we do something like user input and line. Oops. Okay. You see, you notice how I said earlier, strings were just an array of characters. Well, like this, we're going to be getting the second character in the string. Hello, E. E is the second character in the string. And that is why the number 1 got that. Now, what happens if there's no second character? Let's try. H, it's nothing. That's because there's nothing there. What else can we do with this? Well, we can process it. We can check if the user has inputted. Let's see. If user has inputted a specific string, I will do something like cout hello back. Or actually, let's do user. We'll call the user classic. All right. So if the user inputs hi, exactly like so, then we get hello user out. Click F5 to build and run. I love that shortcut. It's my favorite thing ever. Hi, hello user. What happens if we don't put hi? We put bye. Nothing happens. That's because right here we have an expression. So we have if the user input is equal to this means equal to, this means not equal to, hi, this other thing. Now you can do a variety of things in these if statements. So if basically runs stuff, whatever is in the parenthesis will run if whatever is in here is true. There are other things you could do. You can do stuff like comparing numbers, if it's greater than, less than, if they're not equal to, and whatever you want. Of course, you can't do if is greater than or less than in this case because, well, that'd be a bit odd to compare strings like that. But you could compare their lengths. And you can do multiple comparisons right here. If you do something else like user input does not equal by. You might have noticed though that there's an error in this logic. It's programming, like you have to understand the language, right? But really it's about converting your thoughts of logic into a language that the computer can then turn into machine code. And in this case, the logic follows as such, like so. If the user input is equal to hi and the user input is not equal to by, then print this. Well, it's a bit redundant, right? If the user input's already equal to hi, then obviously it's not going to be equal to by. So that's one of the things you should be taking into consideration. Of course, there are certain ways you can do stuff like this. Like you might use the same variable, compare it twice if you want to see if it's within a range. But there are also other ways to do that more efficiently. But right now, we're going to use this. See, these little pipe characters, these two lines, two churros, that also means or. So as you know, there's like logic statements like and, or, that's what this is. This is or. Obviously the other one was and, 'cause what else does that ampersand mean? So basically what this means is we can do something like hello, run that. And when we input hello user, exactly, perfect. Now, right here, if we put dot after the string, we can access more capabilities. These are like sort of built-in things into the string, right? Because technically it is kind of in a way a class, but we'll talk about that. We'll talk about that in a future video. But for now, let's just treat it like it is. These are sort of just like functions that you can run on the string itself. So if you just go down, you can see like all these different things. You can use the arrow keys or you can scroll. Let's see. Let's get the length. If the length is greater than 10. Oops, we got a minor error here. Let's see what the light bulb says. Pointer to a bound function may only be used to call the function. There we go. So you do have to add these, by the way. And that's because, like I said, it is in the way a function call. And when you call functions, you have to put the parenthesis to indicate your arguments, in which case there isn't any because you're just getting the string, the length of the string. So click F5. So now if you do just type in random characters, hello user. So right here we got if it's equal to hi exactly, or if it's less than 10. Once again, it's redundant because hi is shorter than 10 characters. So this is sort of kind of useless because this case is covered in this case, like sort of like a bubble map, you know. What else can we do? You know, because like, what if I want to run the same piece of code multiple times in different places in my program? Well, that's where functions come in. And this int main is a big function in and of itself. But let's try something else. Let's try string. And let's see, get every other char. Great. This is another function. So what you put here, like right here, we put int main, integer main, and return 0. When you put this basically means what the function is going to return, and this is returning a 0 to the system itself, which means the program ran great. Get every other character, or every other char. We're going to go ahead and actually add a parameter to this. So when you have functions, parameters is basically what you're taking into the function. And you can actually define parameters here, which can be used as like launch arguments, but we'll do that some other day. String, we'll put input, we'll just call it input. So what do we do now? How do we get every other character and output it to wherever? Or not wherever, just wherever this function is called. Well, let's start by defining a string, new string. Okay, this empty string will be used to store every other character. Now, what do? This is where I introduce you to the beautiful loops. Sort of like this. So basically for whatever is in here, run this. So we can do something like for input dot length. Let's see what's going on here. Okay, I don't know why this is waffling. Greater than I plus plus. Oh. Also int I 0. Okay. So let's go through this together. So you can actually declare variables right here. And what we've gone ahead and is declared a variable called I. I is equal to 0. Now, what do we do then? For every input, or not input length, for the input length, whenever input length is bigger than I, run whatever is in here and add 1 to I. So the plus plus means increase by 1, minus minus means decrease by 1. So it's sort of a way to increment things easily. Because normally what you'd have to do is something like I equals I plus 1. You don't have to do that because you got the plus plus. And you might be wondering also right here, see, that's a useless tip. Why isn't I working right here? It's because we declared it down here. So once again, you must use variables and anything you declare below the declaration for C++. It's might be different for other languages, but for here, yeah. Great. We got this thing, so now it's gonna run that for the length of this inputted string. How do we do what we want to do now? Well, it's easy. So we can actually do new string dot append. So what does append do? Oops, I meant to. Okay, I'll have to type it out then. Append adds to the string, and okay, this is waffling again. It's not always useful. Append basically adds to the end of a string. So you had like a stack of boxes. You put another box on there. Good job. You appended to the stack of boxes. That's kind of how I like to think of it. And what we can actually do is use the fact that I is incrementing alongside the length. So every other character is basically switching between include, don't include, include, don't include. And a pattern, which you might have noticed, is that this is incrementing, and also that numbers switch between odd and even. Even, odd. Even, odd. So what we can do is something like this. So if, just do something like that. I click, this is why I also like Visual Studio. I know other programs do it, but I also like Visual Studio because it's just generally nice. I clicked this button right here. I guess you didn't see it, but I clicked the curly bracket and like it formatted it for me in like a nice way. So if I is modulo 2 equals 0. So you might remember, what is modulo? Or if you don't know what modulo basically means what is the remainder when you divide. And this is one way to find out whether something is even or odd. If you divide 0 by 2, there's no remainder. Divide 1 by 2, 1 is remainder. So this basically means for every time that there is no remainder, aka it's an even number, append. What do we append? We're going to go ahead and append I. So we'll take input I. This is where we use the thing itself. What is this thing on about now? All right. Anyways, what I was on about before, I had to make a quick fix actually. So append actually I now realize that append actually needs, should probably read. This is why you got to read, by the way. It needs a size, and then this is where it takes the character. So let me actually reverse this. There we go. So this thing is really coming in handy. Now, for the length of the string, once I is bigger than length, it shall stop running this. But until then, it will iterate through each character of the string. If the iteration, which starts at 0, is an even number, adds to the new string. If not, do nothing and repeat. That way it'll add for every even number, which is basically getting every other character. So we do something like return new string and boom. Now let's try calling that here. Let's see out, and we'll do, what's the name of the thing? Get every other character. Okay, get every other character and user input and end line. Okay, so right here, actually, where you use variables, anywhere where you can put a variable, you can also put a function call. That's because the function, what the function returns is pretty much treated like a variable, like out here. So if you do this, this is exactly the same thing as a string, and that's how it's defined here. So, and that's what it'll always return. So it's sort of like something really useful for when you're like connecting things together in bigger applications. All right, now that we got this, let's try typing in hello world. HLO. Great. Now what happened? Why didn't they get that thing afterwards? See, that's a little thing about cin. If you put spaces in your input, it's going to cut off. Now there are ways to fix this, but I'll cover that in a future tutorial because this is actually getting pretty long. But this is generally the basics of the program. So let's actually try something else. 1, 3, 5, 7, 9. See, you got every other number. 1, 3, 5, 7, none. Great. And this is something that you will have to do a lot in programming. Well, maybe. It really depends on like what kind of programs you develop, but this is sort of like a little algorithm to figure out the every other character. Now, that pretty much wraps up the whole tutorial. Actually, let me explain one more thing before the end of the video. So, you might have noticed that we declare I here, but if we try to do something like I plus plus here, it's not going to work. So, in C++, there's this thing called scopes, and it's a thing that's in pretty much every programming language. And what that means is that when you declare something, whether it be a variable or a function, you're defining it within a certain scope. Now, functions, I wouldn't necessarily say they're exactly the same thing as variable in terms of scopes, but if you want to use it in, like, say you have another source file, you have to do certain things with header files in order to access the functions between the two files. Similarly, you'll have to do the same thing for variables if you want to access the same variable across two different files. But you might be wondering, if you can't access something outside of the function it's declared of, then how are you supposed to access something in a whole different file if that file doesn't have the ability to just like pull it from the function? Well, that's where declaring things globally comes in. And it's like something to be kind of careful with, but that's where you do something like int global var. So right here, this global var is accessible by everything in this header, or not, sorry, in this source file from below its declaration. So if we were to do global var plus plus, boom, it works. If we do something here, same thing, boom, it works. That's because this is global. And if we wanted to access from another file, we'd have to do a few things in the header files, which I'll explain next time. But that's sort of like a way to synchronize like information across multiple functions without having to like be so tedious with storing something continually in a single function. But then again, it's more useful for if, like, say you want to do something like int even or odd equals 0. So you might have noticed right here, whether this is even or odd, you could do something even or odd. Usually when you declare something like this, like it's supposed to be like changed by the developer, like a little setting, it's sometimes named fully, it's sometimes fully capitalized and has like underscores. You can put underscores in the names of variables. You can end them in underscores. So yeah, you can begin them with letters and you can have numbers in them, but you can't begin them with numbers. So by defining this here is you can like change settings, and that'll change whether you want every even character or every odd character. So that's sort of another use for global variables. But that pretty much wraps up the whole video. It's been almost 40 minutes. I hope this was useful. I hope it explained things well. And if you have any questions, let me know. Thanks.